Oh, you found me. All right, first, I'd like to apologize. Lots been going on in my life, so I didn't get an opportunity to make this exam until just now, and I really am sorry about that. Hopefully you're tuning in for August 2016, August 16th, 2018. This one's going to be part 1, and I promise my handwriting will get better, maybe. Problems 1 through 12. My name is Mr. Krause, but for the next hour, you can call me Mr. Key. Now, during this video, I'm going to help you find out how I'm going to help you solve these problems the correct way. I'm going to show you some tricks, and I'm going to show you some ways you can use your calculator to really help you to find the right answers, okay? So, before I do that, I gotta wait. Where's my Dunkin' Donuts coffee? Oh, my God. Rest assured, that is Dunkin' Donuts freshly brewed coffee from downstairs. Unfortunately, I've moved. I sold my house. I'm in a rental. All my stuff's in a storage unit, and I don't get to move into my house for another month. So I'm sort of in a room, sweating to death, recording this video for you. But let's get going. Enough whining. Here we go. First problem. Now, first way I'm going to show you always on how to do these problems is the correct mathematical way. And then I'm going to show you some tricks, okay? Don't just jump to the tricks. You really need to know how to do these mathematical ways, because if this is a part 2 question, which it easily could be, you got to be able to solve it. All right, so we need to solve for x. This is an exponential equation, so I know, wait, how do you know it's exponential? Because the variable is in an exponent position. So here's my exponent. And there's my x. So if the x, or the variable, is in the exponent, it's an exponential equation. So we're eventually going to turn this into logs. Now, because it's e, we're going to turn it into a natural log, eventually. First thing we got to do is, what I always say is get the weird thing alone. We like to call this getting the solo alone. You know what I'm saying. Yeah, you know what I'm saying. We get the solo alone. Now, if you don't know this young man, Mr. Solo, you know what I'm talking about. Got a couple shout outs this year for my 2019 students. So this is going to be e to the 0.3x equals. Now, I don't bother to put this in my calculator. 5,918 divided by 87. It's going to give me an obnoxious decimal that you might accidentally round and then not get the right answer. Although on this problem, since these answers are so ridiculous, it should be obvious. So here's what we're going to do. Now we're going to turn this into a logarithm. So we're going to do natural log. Now, the base of all natural logs is e. But I'm not going to be able to put that in my calculator. But I'm going to put it there anyway. Now, in my class, I'll always ask, what are logs equal to? And then I hopefully hear a crescendo of exponents. And that's right. Logs are equal to exponents. So I'm going to put the exponent on this side, 0.3x. And then this little missing piece goes right here, 5,918 divided by 87. Now, to finish solving for x, I'm just going to divide by 0.3 and divide by 0.3. And now I'm done. That's it. That's all I do. I come over here to the old calculator, and I go, okay, control division, control natural log of control division, 5,918 divided by 87. See how I don't have to bother putting that in as a decimal, because it's sort of annoying. 0.3, I hit enter and I get 14.00600. Now, on the day of the Regents exam, I don't really recommend you doing it that way. Like, for example, what you can do is just say, okay, I'm going to try these. I'm going to try, where'd my pen go? I'm going to try this one right here. And let's see how that works. So I come over to the old calculator, which is right here, and I say, okay, this problem says 87, control E, oops, excuse me, wrong one, just E. Actually, that's not, sorry. What's this answer? 0.583. So I'm going to take 0.583, and I'm going to store that into x. And you can do this on the TI-84 as well. It's called the stow button. You just stow it into x. I'll press enter, and then I'm going to type in the answer. 87e to the 0.3x. Now, what I'm hoping for is 5,918. Ain't even close. So then I'm going to say, okay, what's the next answer? 1.945. 1.945. And I'm going to store that into x. Now, I'm not going to retype that line. I'm just going to hit the up arrow, this line right here, until I get that, and I'll hit enter. Ooh, no, not even close. And we already know the answer is 15.066. I'll store that into x. And I type this in. And I hit enter. And I get something very, very close to 5,918. So you see how I was able to use the answers and work backwards from the answers and the calculator to get the right answer without really any math. Okay? Now I'm going to try to reduce some of your stress. New York State has made this test so utterly easy to pass. All you have to do is follow what I show you and help you with, and there really shouldn't be any reason to pass. Now, you need to study. You need to know how to do these problems. Many of these questions can be done using the calculator, and I find that unfortunate. I think New York State should stop that and to have a non-calculator part of the test. But, alas, they're not, so you are taking advantage of it. Let's look at the next problem. Question number 2. A researcher randomly divides 50 bean plants into 2 groups. One group by the window and receives natural light. Second group is going to receive artificial light. He records the growth of the plants weekly. Which data collection method is best described in this situation? So let me go through all these real quick. By the way, you should know for certain that this is a controlled experiment. That's it. A controlled experiment always. By the way, if you ever have to say on a part 2, how do you create a controlled experiment? The one key word you have to use is randomly. Do you see how they put random here? Where did my pen go? Randomly selected. So 2 randomly selected groups. One gets the control experiment. One gets the treatment or something going on with it. The other one doesn't get anything, and then you compare the results. An observational study. An observational study, this one right here, is when the people being observed don't know what's going on. For example, if you wanted to watch and find out how many guys wash their hands when they leave the bathroom, right? You're not going to stand there and go, hey, Johnny, did you wash your hands? Oh, you did? Okay, great. And then, Billy, did you wash your hands? Oh, you did? Great, because every boy's going to come out and say, of course I did, of course I did. You know, but they're not going to say they didn't because that's disgusting, right? But that would be what's called response bias. When you ask a question and they're going to change their response, that's called response bias. It's another little thing. But observational studies is when you stand back and watch what goes on, but the person doesn't know it. So you kind of like discreetly watch what's going on. A survey is when you ask people, but that gets lots of bias. And a systematic sample is when you say, okay, I'm going to ask the 4th person and then every 23rd person after that. And you create a system to get the data randomly. So you're not just asking the first 10 people or the first 20 people. Okay, that goes through those. Next problem. All right, which operation would... Now, you guys got to... Hopefully, your teachers have been telling you over and over again that New York State likes to add the word false, not true, untrue. One year they had not unfair. That guy should be never writing a question again. Not unfair. Who writes not unfair? It's question 12 on the August... it's either question 12 or question 10 on the August 2017 exam. I know that because it made me so mad that year. You should go look it up. It says not. By the way, the whole problem takes a page too, so that guy should never be writing a question. Although it was a good question. It's just worded weird. So nots come up all the time. If you see the word not in there, hey, pay attention. 3 are true, 1 is not true. Be careful. Ooh, Dunkin' Donuts time. So let me tell you what these are going to be. A polynomial expression is something like a trinomial, a binomial. A polynomial means with lots of terms. So if I was to take these two and just add them up like this one, I would get x squared plus x plus 12. That is a trinomial. That is a polynomial expression. If I was to subtract them, now, hey guys, pay attention to subtractions. Okay, they're very, very difficult. You've got to be really, really careful. When you do those, you got to go, okay, I'm going to take x squared plus 9, and I'm going to subtract off x plus 3. Now, do you notice why it's important? Because if you didn't have the parentheses, you would not be distributing. Negatives kick your butt on these tests, so don't let them kick your butt. This is really just a minus x and a minus 3. So here I would end up with x squared minus x and then plus 6. This is also a polynomial. Now, if I multiply these, of course, you got to put them in parentheses, so you remember to double distribute, or whatever, or FOIL, or whatever your teacher decides to call it this year, whatever is politically correct this year. Nobody liked FOIL. I don't know why. Double distribute. X cubed plus 3x squared plus 9x plus 27. This is a polynomial with 4 terms. It is a polynomial. Now, the reason this is the correct answer is because when I divide these, I end up with x squared plus 9 all over x plus 3. This is not, the numerator is not factorable, so this you can't simplify. And this becomes a rational expression. And a rational expression, if you remember correctly, is a fraction. Ooh, I love fractions. No, I don't. All right. I'm going to pause for a second. I'll be right back. You won't even know the difference. Okay, the page changed, and I came with my coffee, so now you know why it changed. I had to stop it. You got to stop it every once in a while. That way, if I lose the thing or if my computer crashes, I don't lose all this great, wonderful things I've said. Okay, here's what we got. He says, so when I first read this question, I was a little bit confused. I didn't know what was going on. I hate when they do things like this to try to get all mathematical and fancy on me. What they're saying is, this thing right here is m of x. Whatever it is, it's m of x. And this is a polynomial called p of x. And so he wants us to consider these graphs. Now, let's talk about m of x for a second. Do you notice that it's going up in both directions? That means it's an odd degree function. It doesn't necessarily, whoa, what the heck am I talking about? Back to crazy, trig it up. That means it's an even degree function. Doesn't mean it's an even function. It means an even degree. Now, in order for you to be able to test, by the way, if it's an even function, they got to be both pointing in the same direction, and it has to be symmetric with respect to the y-axis. So this appears to be an even degreed polynomial because it appears to be symmetric with respect to x-axis. Now, if you look at the answers, that has nothing to do with the problem, but it certainly does help. Now, I always told my kids when we went and did these problems, I said, okay, count the number of humps and bumps. Now, we call these things relative extrema. This is called a relative max. These are called relative mins. In fact, in this case, they're absolute mins, but generally we call them relative mins, but in this case, they're absolute mins. So you see 3. That means this is probably a 4th degree polynomial. Probably, not necessarily, but probably a 4th degree polynomial, which means it should have 4 roots. Now, I only see 2. I see 1 here and 1 here. That means the other 2 should be imaginary. Okay, let's go take a look at the answers. This is, remember, is m of x. So m of x has 2 real roots. That's true. That's true. M of x has 2 real roots. That's true. M of x has 3 real roots. Not true. M of x has 4 real roots. Not true. So we're down to 2 choices. But the other one, now this is an odd degree function. Now it doesn't mean it's an odd function. In fact, this one's, actually this probably is, no, it's not an odd function because it's got this here. But it doesn't mean it's an odd function, but it is an odd degree function, which means it probably should have, because it's a 3 real roots. But we're going to have to graph it using our calculator in order to figure out, ooh, wrong place, in order to figure out what's going on. All right, so we're going to go over to the calculator. Take us a couple seconds. 3x cubed, 3x cubed, plus x squared, and then minus 5x. And we press enter, and we see, look, we see right here, 1 root here, 2 roots here, and 3 roots here. So this has 3 real roots. So when I come back to my problem, I want the one that says p of x has 3 real roots. And that would be choice 1, which ding, 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 is the big winner. All right, next problem. Which expression is equivalent to this? Okay, I'm going to show you a couple of different ways to do this problem. The first way I'm going to show you is the way I would ask my kids to mathematically do this first, and that's by what's called the remainder theorem. Hopefully I spelled that correct. This is what we think may be a factor. Now, if it is a factor, then the root would be x equals -6. So let's say I assume this function up here in just the numerator is called f of x. If I check f of -6, what I will get is the remainder when I do long division. Now, why is that important? Because the remainder on this one is 86. Since there's nothing here, the remainder is 0. Since this is here, the remainder here is 14. And since I have nothing here, the remainder here is also 0. So if I get a remainder of 0, then I'm down to either this one or this one. If I get a remainder of 86, the answer is number 1. And if I get a remainder of 14, the answer is choice 3. So I'm going to take -6, and I'm going to store it in my calculator. By the way, I always start these fresh. So I take -6 and store it into x, and I press enter. And then I'm going to type the problem. I'm going to look down at my sheet so I can do this way. 2x raised to the 4th. Plus 8x cubed plus 8x. This takes a little bit of time, but you're going to tell me, I'm going to show you that it doesn't take as long as the other ways to do it. X squared minus 6x, and then plus 14. So whatever I get is the remainder had I done the long division. 14. There we go. So my answer is this one, choice 3. So that's one way to do the problem. Now, while I'm working on my calculator, let me show you a real quick cheat. Let's say I take any value, and don't use the one they got. We're going to take -6.254. Again, I can choose any number I want. We'll store that into x. Okay, now I'm gonna use what I already did here. Let's assume I'm going to put this in the numerator, and I'm going to divide by parenthesis x plus 6. Now, what you're going to see, is it x plus 6? X plus 6. What you're going to get is some crazy decimal. Psh, who cares? But what I'm saying is, notice how this, by the way, fixed it. This is exactly how the problem looks. So I get some crazy decimal. Then what you can do is check all of these answers. Now, since 1 and 3 look a lot alike, I'm going to show you what it doesn't look like and what it does look like. So, it's 2x cubed. I'm showing you just a different way to do the problem. Plus 4x squared. I'm just putting in answer 1 right now. Plus x minus 12 plus, now hopefully you see that this is exactly what x plus 6. So that's answer 1. Now, if answer 1 was the answer, I should get negative 694.5333. Ooh, it's really, really close. It's really close, but it's not right. So now I'm going to check answer 3, which we know to be the right answer. Now, I know this has to be 14. And something else changed. It's minus 4x squared and minus x. So minus x and minus 4x squared. So if this is right, it should be negative 694. Oh, and there's no minus 12. So this should be answer choice 3. 2x cubed minus 4x squared minus x plus. Okay, good. And if this is right, it should be negative 694.53524365. There it is. So I'm able to store a number in for x and check the answer that way. All right, so now I've showed you 2 ways to do it. Now what I'm going to do is I'm going to actually do the long division. This is going to take me a couple of minutes. If you're not good at long division, this might be a nice time to just check your work. It's not that difficult. I'm going to do this. 2x to the 4th. I'm actually going to do the long division. Now, because this was a multiple choice question, I don't believe that they expected you to do it this way. I believe they want you to do what's called the remainder theorem. Oops, that should be 14. That thing I did first and check that negative 6. All right, so here's how it works. I've got to figure out what do I have to multiply x by to get 2x to the 4th, and that would be 2x cubed. Then I'm going to take it and multiply it by both of these terms. So that's 2x to the 4th, and 2x cubed times 6 is plus 12x cubed. Now here's the one thing lots of kids forget. You got to change the signs and subtract right? These go away, and I end up with negative 4x cubed. Now I'm going to bring down this. I'm going to slide this over. That was too much. I'm going to slide it over so my big old bald head doesn't get in the way. Bring this down, minus 25x squared. And now I want to figure out how many times this goes in. So I said, okay, what do I got to multiply x by to get negative 4x cubed? Oh, that's negative 4x squared. Now, I believe at this point I might be done. Oh, nope, it could be either choice 3. Oh, it could be choice 2, 3, or 4. So we got to keep going. So minus 4x cubed minus, what's 4 times 6? 24x squared. Pshoom. Change the signs. This goes to a plus. This goes to a plus. I end up with negative x squared minus 6x. Scroll down. What do I got to multiply x by to get negative x squared? That's negative x. Negative x times both of those is negative x squared minus 6x. Shabam. Now here's the weird thing about this problem. Change the signs, I get 0. Well, if I bring down 14, how many times does x go into 14? It doesn't. So that's my remainder. Here's my remainder, just 14. And here is choice 3. All right, kids, I've done it a number of different ways. And then that's how you write, this is how you write the answer. There's my answer. All right, finished with that problem. That problem took forever. All right, I'm going to show you a couple of different ways to do this one. I'm going to show you what this looks like. I'm going to do the math first, and then I'm going to show you how to do this graphically, and then I'm going to show you how to use the tables. Okay, so first things first. I've got y equals 1/2 x plus 8. Now, if your teachers did correct job, what they told you was in order to find the inverse algebraically, you switch x and y. So we end up with x equals 1/2 y plus 8. Now, in order to solve this, you got to get y all by itself, but you need some Dunkin' Donuts to help you out. Yeah, this is Dunkin' Donuts. My real cup of Dunkin' Donuts, or my cup for Dunkin' Donuts, is in storage. Oh, that's good. And it's like 90 degrees up here. Now, this fraction drives me crazy. So what I'm going to do is I'm going to take this whole thing and I'm going to multiply it by 2. So that gives me 2x equals. Now, 1/2 times 2 is just 1. Well, that's just gorgeous. That equals y plus 16. Now, again, I just multiplied everything by 2. And then I bring the 16 over, and I am finished. 2x minus 16 equals y. Now, to write this correctly, you should write, oh, they wanted to call g of x. Okay, and then there's my answer, 2x minus 16. Let me show you what this looks like if you tried to do this graphically. And graphically, it's really, really simple. Remember what I told you. There's a number of problems on the New York State Regents Exam that can be done strictly using the graphing calculator if you know what you're doing. All right, so what I'm going to do is I'm going to graph the original, which is control division, 1 over 2x plus 8, plus 8. There's the original. Ooh, can't see it very well. Don't like that. Ooh, really don't like that. So I'm going to stretch this a little bit. I'm going to change this to negative 20, tab, 20, tab, 20, tab, negative 20. Again, what I did was I clicked on one of these and just pressed tab to go around all of them. And I can go around and change those all that I want. Okay, so I'm going to press tab, and I'm going to graph the line y equals x. When you graph the line y equals x, and then you realize and you know that all inverses are reflections over the line y equals x. So my answer has to be a reflection of that blue line over the red line. So I should end up with a line over here somewhere. So I'm going to press tab, and I'm just going to put in first choice, 2x minus 8. Does that look like an exact reflection? Not quite. Not quite. So now I'm going to put in choice 2, which is, I'm going to hit the up arrow, which is 2x minus 16. So I'm going to change that black line, take it 2x minus 16. Now, do those look like reflections over the line y equals x? Yep. Yep. Now, here's another thing. If you go to the table, Control T, and you look at the table, see how you got 1, 8.5? Well, let's do 2, 9. See how I got 2, 9 here? On the reflection, I should have 9, 2. 9. Oh, 9, 2. Sorry, remember the black lines? So there's 9, 2. 9, 2. See how I got 8, 12 here? 8, 12 here? That means I should have 12, 8. 12, 8. 12, 8. Now, if you just went through, let me get rid of the black line. Anyway, the inverses, if you look at their tables, they should be switched. The x and y should be switched. So if you were just to write down the table for the original function and then write down the table for the inverse, the x and y should be switched. Okay, that should be pretty easy to understand. I hope you got that. Okay, I'm going to pause for a minute. I'm going to switch to the next problem, and I'm going to be drinking some coffee. All right, I forgot to switch to the next problem. There it is. All right, kids, I'm going to show you the right way to do this problem, and then I'm going to show you what you really have to do on Regents exams anyway. So let's do it the right way. The right way is to isolate the radical. Again, my job is to teach you how to do math, but more importantly, I want you to get the very best grade on this Regents exam. And the very best grade on this Regents exam is to use all of the tools that New York State allows you to use. All right, which is a calculator. So what we're going to do this mathematically first, just in case it was a part 2 question. You know, in order to get rid of a radical, you got to square it. So if I square that side, put this in parentheses, and square this side. This side gives me x squared minus 4x plus 5. Now, if you're one of my students, I've taught you how to double distribute this quickly. You square the 2x squared. Then you multiply these two together and you double it. So that's negative 20. So that's negative 40x. And then you square this, which is plus 100. Now, for those of you that don't learn that, what you got to do is double distribute. Minus 10 here. This gives me 4x squared. This gives me minus 20 and minus 20. That's minus 40. And then negative 10 times negative 10 is positive 100. Now, this is a quadratic, so we're going to end up factoring it. That means all three of these things need to go to that side. Now, why are they going to the right? What you want to do is look at your x squared. You never, ever want to have a negative x squared. So if I move this 4x squared over here, I would have, and I got to subtract it, I would have negative 3x squared. Now, that's not what we want. So we're going to move all this stuff over. I'm just going to subtract x squared. I'm going to add 4x. And I'm going to subtract 5. I feel like I wrote the problem down wrong. Oh my gosh, look at that. I realize I wrote the problem down wrong. See how that's a negative and that's a positive? Oh my gosh. Lucky I did the problem beforehand, so I realized that was wrong, because that would be here all day. Now some of you are like screaming in the mic, change the problem, you screwed up. All right, I found it. All right, so 0 equals 3x squared minus 36x plus 105. Now, I always look for a GCF. Do you guys know the divisibility rule for 3? If you add up the digits and that's divisible by 3, the number is divisible by 3. So these add up to 9, which is divisible by 3, so I know 3 goes into that. Add up those, that's 6. 3 goes into 6, so 3 goes into that. So what I'm going to do is I'm going to take that 3 out, because that makes my life a little bit easier. And I believe this is 35. So then I'm going to use the answers to help me out, because it looks like the answers are all 5 and 3 and 7. So x and x, and I know 5 times 7 is 35, so this is going to be minus 5 and minus 7, and I get two answers, x equals 5 and x equals 7. Now, having said that, doing all of this work, by the way, which is the mathematical way to do this, that was a monumental waste of time. And the reason it's a monumental waste of time is because when you solve equations with radicals in them, you have to check the answers, because this method oftentimes produces what's called extraneous solutions, bogus BS answers that don't work. So that happens all the time. So you have to check the answers anyway. So why should I go through all of this work? I did it because I want you to learn how to do the problem. But why should I go through all this work if I got to check the answers anyway? Are you kidding me? All right, here we go. We got to go over to the calculator and check them. So the first thing we're going to do is store in 5. Let's go 5, control var x. Now I want to warn you about something, especially on this calculator. Never, ever, ever use the equal sign. We're just going to put this side in, and then we'll put this side in, and if I see that they're equal, then they're equal. There's a reason for it. Every once in a while, this calculator, and all calculators, have a small rounding mistake, and they'll tell you it's false even though it's true. Maybe if I come up with a problem like that, I'll show it to you. Minus 4x minus 5. I plug that in, and then the other side is 2x minus 10. I plug that in. I get 0 equals 0, so we're good. 5 works. So anything with a 5 in it works. This doesn't go. So now I got to check 7. So 7, control var x. And I type in the left side, and I type in the right side, and I get 4s. Works. Now, since I actually went through all this work, I don't actually have to check 3 because I know 3 doesn't work. That's the answer. But just to show you what would happen, 3, control var x, enter, type in the left side. Here's the left side. It equals, oh my goodness, we have a mistake because that turns out to be a negative answer under the radical. And that's a problem. And if you type in the right side, you get negative 4. But the left side produced a negative solution. Right? You're taking the square root of a negative answer. Doesn't work. Okay, there you go. That's that. All right, question 8. Stephanie found, oh my God, I hate these questions. Let me drink some coffee before I get to it. Every single Regents exam has one of these on it. Every single one of them has one of it on it. It's like they found out that, oh my God, this question's tricky. Let's put it on every single one, so let's see if we can trick these kids. All right. So you are duly warned that this problem sucks. I don't like it. Stephanie found out the number of white-winged crossbills in an area can be represented by the formula C equals 551.08 to the t. Now, see how this is 1.08, just talking exponential equations? That's a growth equation growing by 8%. Just putting a little extra information there. Where t represents the number of years since 2010. None of that actually makes any difference. Which equation correctly represents the number of white-winged crossbills in terms of monthly rate? Now, there's the key. Right there, monthly rate, because they gave it to you in yearly rate. So t represents the number of years. So I guess that kind of was important. So t was in years, but they want you to convert it to monthly rate. So let's see how we're going to do that. All right, let's see if I can not make a mistake on this. Okay. Let's take a look at this equation. This equation is C equals 550, 1.08 to the t. Now remember, this is t years. Yes? Okay. So I want this in terms of months. So if I had... let's see. If I had t years. Sorry about that. I had to step out for a second. Woo! All right, here we go. So here's what's going on. Remember, let's see. Let me make sure I do this right. Oh, I hate these questions. So really, this is t over 1. So we're growing by 8% every 1 year, correct? All right, so what I need to do is I need to change this rate. So remember, this is t over 1 year, okay? But I want to change it to months. So I need to have months here. But I have months here and years here, correct? Well, 1 year, so I'm going to change this t to actual months. Well, doesn't 1 year, doesn't that really equal 12 months? You can't have mixed units like that. So really what I have is a mess here. But what I did was I said, okay, instead of t being years, now t is going to represent months. but that was t over 1 year, and 1 year is really 12 months. So here's what we really have. We really have c equals 50. Oops. Control Z. 550, 1.08. Now, what I have again is it's t over 12. Now, there's really a 1 here. Now, is that one of the answers? It's close to this one, but it's not this one. And it certainly isn't this one, because this one is exactly the same as this one, except for they changed the base. So that's not it. So it's got to be one of these other ones. Now, here's what they do. Do you see this fraction 1/12? And this is where this number 1.00643 comes into. It's really this taking this 1/12 and bringing it inside here. So what they're doing is they're raising, where's my calculator? 1.08 raised to the 1 over 12. Oops, excuse me, 12. And that's that 1.066. So that's where they got that. All right, so we got c equals 550, 1.00643 raised to that. Now you can't have t because t was still in terms of years, and we're going to cut this down into monthly little segments. So for every year, we have 12 segments. So we have to multiply this by 12. And that's why choice 2 is the right answer. Now, having said all that, I'm going to be fairly certain, this is the right answer, I'm fairly certain we can pick any value we want for t. Let's just take 2.368 and we'll store that into t. And what I'm going to do is I'm going to type in the original 550 parenthesis. Let's see if this works. 1.08 raised to the t. Let's see, I'm not sure if this is going to work or not. Let's just check. And then 550 parenthesis 1.00643 raised to the 12t. Oh, see how close it is? And it's only that off because I didn't use this whole number up here. I used the rounded estimate. So I guess we could have done it that way as well. Hate the question. I don't know why. They put it on every single time. It's not a great question. I don't like it. Let's do 9. I'm going to show you how to do 9 the correct way, and then I'm going to show you how to do it the way you probably are going to do it on the day of the Regents. So the correct way is to say, okay, I'm going to solve this thing. 3x squared plus 2x plus 7 equals 0. Now, I have only one way to solve this, and that's using the quadratic formula. So we'll do that really, very quickly. Oops. A equals 3. B equals 2. C equals 7. And D, which is the discriminant. Now, if you look at the reference sheet, this part right here is the discriminant. B squared minus 4AC. So that's what we're going to use as far as D goes. I don't know what color I was using. B squared minus 4AC. So B squared is 4 minus 4 times 3 times 7. So 4 minus 4 times 3 times 7. I get negative 80. There alone means I'm going to have an imaginary solution. There we go. That's the answer. Why? Because my discriminant is negative, right? This is negative 80. So that means I'm going to have a negative under the radical, which means I'm going to have a negative discriminant, which means I'm going to have an imaginary solutions. But let's just check it. X equals negative b, negative 2, over 2a, which is 6, plus or minus the square root of negative 80, because I already did all that work, over 6. Now, the square root of negative 80 is really the square root of negative 16 times 5. 16 being the largest perfect square that goes into 80. The square root of negative 16 is 4i. So I get x equals negative 1/3 plus or minus. Now, 4 over 6 reduces to 2, so 2i square roots of 5 over 3. There we go. Now, Day of the Regents exam. Please don't do that this way. Let me show you how you do this problem. It's so fast using the calculator, and of course New York State allows us to do this, so let's just do it. Let me clean this up so we don't have all this mess here. And I'm going to take -2 and store it into x. So -2, control var x. I press enter. I type in the left side. 3x squared plus 2x. Bam, 8. Oh, should be equal to -7. See how it should be equal to -7 here? Doesn't. So that doesn't work. So choice 1 is now officially done. Let's try 2. I'm going to do 1. 1, control var x. Now I could have done the 7/3, but 1's so much easier. Type in the right. I get 5. Should be -7. It's not. That goes away. Let's try choice 3. Now choice 3 is a pain in the neck. Control division. -1/3, so -1/3 plus, you can't put them both in, control division, 2. Now you can't just type an I, you got to come over here and use the actual I button, I, square roots of 5/3. And we're going to take that and store that into x. And, oh, this might be a good example of where, oh, but I don't know. We get -7, right? If you use the equals button, your calculator might crash that. But you see how that equals -7? There we go. There's my answer. All right, I'll be back in a little bit. Okay, let's talk about this. The average depreciation. Depreciation, by the way, is a vocabulary word, means to go down. So we're going to go down by 8%. Now remember, when we're doing exponential growth, if it's growth, we're going to add 8%. If it's decay, we're going to subtract 8%. So this would be 1.08 for growth, and this would be 0.92 for decay. So let's see what we got here. We got a boat that's worth 75 grand. Dang, I wish I had a boat worth 75 grand. Oh, wait a second. Recursive. Did I say recursive? Do you know what recursive means? Recursive means you better have 2 lines. 2 lines. That means you guys are out. You guys don't have 2 lines. Not only that, do you see how this, oh, this is 0.08. They're trying to confuse you. And 1.8, these don't make any sense at all. So let's get rid of those. They are not recursively defined. So now we need to recursively define it. Notice a sub 0 is the same. A sub 0 is the same. Okay, that's not a problem. Now, which one is a 8% depreciation? 0.92? Wait a second. That's a depreciation and that's a depreciation. Okay, so here's the thing about recursively defined functions. They have to have 2 lines. The first line being the first term, in this case 75,000. And the second line has to have a sub n minus 1. What this represents is the term before. A lot of teachers call it the before, right? The term before. And that's why this is the correct answer. This don't make any daggone sense. None whatsoever. Let's do this. Is that it for that question? 11. Okay, I think the way they asked this question is awful. Absolutely awful. Now, I'm going to show you the way you should have done it. I am not going to do it using this thing. This here, well, maybe I will, but this here was really designed to confuse you. You don't have to use this. You can use your reference triangles. Check this crap out. They told you that cosine was equal to 7/25. Now, if you remember, some old hippie caught another hippie tripping on alligators. Whatever. That's a little weird. So cosine is adjacent over hypotenuse, 7/25. And we can find x by simply doing the Pythagorean theorem. X squared plus 7 squared equals 25 squared. X squared plus 49 equals 625. X squared equals, was that 576? And then x equals, taking the square root of both sides, 24. Oh, That means this missing side is 24. Now I go, okay, you want to know what tangent is? Tangent is opposite over adjacent, 24 over 7. Now I'm going to guess, I'm looking at you right now, I'm not looking at those answers. I'm going to guess, looking at you, that there's two of those. One's positive, one's negative. Oh, yeah, there they are. 24 over 7. Now, you have to remember this. And this is something you probably should have started the problem out with. And I'm going to get rid of all this stuff. You should have probably started the answer with saying, oh, we're in the fourth quadrant. Now, hopefully your teachers taught you this. All students take calculus. In other words, all things are positive here. Sine and its reciprocal function cosecant are positive here. Tangent and its reciprocal function cotangent are positive here, and cosine and its reciprocal function secant are positive here. So if we're in the fourth quadrant, cosine is positive, tangent is negative. There's the answer. Now, even if you did it the way they ask you to do it, which is to use this crazy formula, I don't know why you would do this, but if you did, you would go, okay, cosine is 7 over 25. So what I'm going to do is I'm going to go, okay, sine of theta squared. I'm going to write it like this one, plus cosine of theta squared equals 1. So now I'm going to find out what cosine theta is. Now, I don't know why anybody would do this problem this way. It's almost like they tried purposely to trick you to do it this way. You know what? I'm not even going to do it this way. It is so utterly difficult to do it that way. But I am going to show you another way to do this one. This one's even easier. Cosine theta equals 7 over 25. Yes? Okay. So if I bring the cosine over to this side, in other words, you have to take the inverse cosine, because in order to get rid of cosine, you inverse cosine it, and I come over here and I inverse cosine this, I'll find out what theta is equal to. So I go, okay, let me clear this crap out. Inverse cosine, there's inverse cosine, of 7 divided by 25. And I get that. So my theta is 73 point not that. So that's what theta is. Now they said, okay, what's the tangent of theta? Okay, let me find the tangent of theta. So I go, okay, the tangent of theta is that. Now, it's a decimal, so you got to come over here and say, okay, 24 divided by 7 is also that same exact decimal. Notice it's off a little bit. See, right about here we get off. Whoa. Oh, sorry. 24. I didn't think it was going to be that far off. Okay, it's not. It's actually not far off at all. Okay, it's exact. Okay, so it's 24 over 7. You still got to know that it's negative in the fourth quadrant, which means that. Now, I would never have done this using this formula. This is just crazy, stupid crazy not to do it that way. You can either use the inverse cosine or your right triangle trig. And the right triangle trig is quick. But you have to remember, okay, here's how you should, I know I'm harping on this same question, but here's how you should have started the problem. Oh, and this is how you can do these on the Regents exam. Oh, we're in quadrant 4. I know tangent's positive in the fourth quadrant. Okay, now it's got to be one of those two. So that way you don't pick the wrong answer. All right, last problem for this video. Last problem, and then you get rid of me. Ooh, now here's a question I kind of liked. So I'm going to show you again, I'm going to show you a way to do this problem the correct way, and then I'm going to show you a way you can use your calculator. So you need to remember this. We're going to turn all of these into rational exponents. In other words, we're going to turn them into a fraction. And you have to remember the outside number is the root. That's the root. So the first one is going to be x. Now the root is 3, and roots go in the denominator. So this is x to the 2/3 times. Now this is really what's here is a 2. So this one right here is going to be x. Again, the root is 2. The exponent is 5. And the bottom one, I got a root of 6. So x to the 6. And then, oh, there's a 1 right there. So that's 1/6. Now, okay, I've done that. Now, when you multiply like these, you add the exponent. So I get x to the, all right, 2/3 plus 5 over 2. 2 divided by 3 plus 5 divided by 2. And I'm not typing anything. 2 divided by 3 plus 5. 5 divided by 2 equals 19 over 6. 2 over 3 plus 5. 2 over 3 plus 5 over 2. 2 over 3 plus 5 over 2. 2 over 3. Okay, I get 19 over 6. All over x to the 1/6. Okay, now when you divide, you subtract the exponents. Well, 19 over 6 minus 1 over 6 is 18 over 6, which is 3. Now, having done all that crazy math, if the day of the Regents, your brain just shuts down and you can't do this right, come on, baby, let's do it the other way. All right, what we're going to do is we're going to pick any random crazy number for x. Don't pick any normal number. 2.357, look at that, picking all primes. Store that into x. And then I'm going to type in the original, control division, control root, and this is the third root of x squared, so third root of x squared, and then get out of that, times control root, this is just square root, so I'll leave that as squared, x to the 5th, all over control root, the 6th root of x. And I'm going to get some stupid answer. Now I'm going to type in my answer that I came up with, x cubed. Are you kidding me? Are you kidding me? All right, kids, that's it. That's the end. Listen, if you haven't hit the subscribe button, please hit the subscribe button. Also, after you're done taking the Regents exam, check back here. I'll have the video up as soon as I can. But let me know how you do. I'm really interested. Hopefully this is helpful, okay? That's it, kids. Catch you on the flip side. Don't forget, drink Dunkin' Donuts coffee, and please take care of your friends and take care of each other. Goodbye.